Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we are working on the August 2016 New York Algebra 1 Common Core Regents exam, problem number 33. If you want to find these exams online, they're freely available for you. Go to nysedregents.org, click on the appropriate tabs, and all the exams are freely available to you. So here's the problem. The data table below shows the median diameter of grains of sand and the slope of the beach for 9 naturally occurring ocean beaches. And I do look at the data very, very cursorily. So median diameter of grains of sand in millimeters, it looks like it goes, okay, it looks like it's going up. And then the slope of the beach in degrees, it looks like it's maybe going up also. And then that's all I look at, that's all. Write a linear regression equation for this set of data, rounding all values to the nearest thousandth. And then using this equation, predict the slope of the beach to the nearest tenth of a degree on a beach with grains of sand having a median diameter of 0.65 millimeters. This is a very classic problem. And this can appear as a part 1 question or part 2, 3, or 4. Right now it's a part 3, so it's a 4-point question. So I definitely want you to know how to do this and follow along with us. So what we do, uh, let me start the calculator over, because there's something that you need to see. I go to enter the data. I go to stat, and then I go to edit. Okay. Now this is how I edit the data. So I want to show you something near the end after the fact. Okay. So what I enter the data as, let's see, the x values go for the first list, so 0.17, enter 0.19, 0.22, 0.235, and then another 0.235. Yes, you do have to enter that. You have to enter it in the same exact order that it appears, whether it's given to you in order or not. Because the x values are going to correspond to very specific y value, like 0.3 corresponds to 1.5 when you make the second list. So 0.3, 0.35, okay, 0.42, and 0.85. Enter 0.85. Okay, so then we enter, that's all our list of x values, and then the y values, we enter those, 0.63, okay, 0.7, 0.82, 0.88, 1.15, 1.5, 4.4, 7.3, and then 11.3. And now, by the way, this does tell you, like over here, it's L2 coordinate 10, which means this is the 10th element of the list that's empty. Each list has 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, which means that the last element should be number 9, which it is, in fact. So we know we've entered the right number of coordinates. So now, how do I calculate the linear regression equation? I go to stat, calc, click on stat, go to calc, and then it goes, notice it says here linreg ax plus b. That's where I go. If it was a quadratic regression, cubic regression, quartic regression, there's a lot of other versions of a regression, and they can and will ask for those, but this is a linear regression, ax plus b. L1 is the x coordinates, L2 is the y coordinates. There is no frequency list. And store reg EQ means if you want to store the equation. So I'm going to store it just to show you how to store it. You press vars, go to y vars. The function is number 1. And then I'm going to store it as, let's say, y1. You can store it to y2, y3, whatever y value you want. So I press enter and then I calculate. Okay, and then I noticed that y equals ax plus b is given to me where a is 17.1593 long decimal and b is negative 2.475925196. We do have to give the decimals to the nearest thousandth. Okay, so we got to follow that as a rule, and we do. So y is equal to a is the slope is 17.15. The next number is a 9. The one after is a 3, so we keep the 9 the same, times x plus a negative number, so minus 2.47. The next number is a 5, but the one after is a 9. We round up to a 6. Okay, so that is the answer to part one of this problem. That's 2 points right there. That's 2 points. So if you know how to plug these data points into the calculator and get the list, you can get 2 points very quickly. The next one, using this equation, predict the slope of the beach to the nearest tenth of a degree on a beach with grains of sand having a diameter of 0.65 millimeters. So things to know, nearest tenth of a degree. Here's the median diameter of 0.65 millimeters. This is an x value. Predict the slope of the beach. This, according to the data, slope is a y value. Okay, so now we know what we have to calculate. And a very common question that I get asked is, do we have to use this equation? Meaning, can we just use this equation with the decimals as long as they're given to us? The answer is yes. They said using this equation. Why test them by using the wrong equation? It doesn't make sense. So we have to use the equation that they said to use. So now, just as a check, x is 0.65, which falls between 0.42 and 0.85. So we should expect the linear regression estimate to be between these numbers. So should be close to here. It should be close to there. Remember that a linear regression equation, it doesn't have to be exact. Because it's a model. Whereas the data is actual data taken at beaches, the model is a tool used to predict that if we were to go to a beach with 0.65 millimeter grains of sand, what would the slope possibly be? So we do that using the equation that we calculated and rounded. So 17.159 times x is 0.65. Minus 2.476. And we get 8 point, and now this is the nearest tenth, so 8.6, the next number is 7, so we round up to 7. 6 gets rounded up to 7. And do not put units. Okay? If you put this is it. On the chemistry test, they will ask you for units. On the physics test, they will ask you for units. However, on the math test, they do not ask you for units, and they don't give you extra points if you put the correct units. And not only that, but they penalize you if you give the wrong units. So it can only hurt your grade if you put units on your Regents exam, and then you end up putting the wrong units. So do not put units in this example, in the math example. So this is 4 points right here. Very short amount of writing. We're done. So let's do an extra problem that we created on our own. But what I wanted to show you, hold on, I'm sorry, quit, is that when we put the linear regression equation, right, we ended up getting A and B, but I know a lot of you are used to getting the correlation coefficient. And that's an important part because on the multiple choice questions, the correlation coefficient is something that's asked for, but it doesn't appear here. So, and it's not. You can expect the school to reset your calculator if they choose to. So you might not see it. You have to know how to get the correlation coefficient there. There's a function called catalog right above 0, and the catalog is the list of all the functions. All the functions. What do? We scroll down to diagnostics. Okay, we keep scrolling. Diagnostics. And there it is, diagnostics off, diagnostics on. We want to turn diagnostics on, so we press enter and enter. Okay, so if you do stat calc now, the one variable statistics in the linreg ax plus b, enter, enter, enter. We've already stored the equation. Calculate. Now we see r squared and r. Those, if those are given to you now, you have to know how to turn diagnostics on. So again, it's above catalog. Go to scroll down to diagnostics on, press enter, enter, and they're on. So let's do the practice problem that we created for you. Here it is. It definitely pause the video, try it on your own, and if you get the same answer as we do, hit the like button and subscribe definitely, because these videos are definitely helpful. And let your friends know that these videos are available, because the reason we make these videos is for viewers like you who can be helped by these videos and need a free resource to study from. So here's the problem. The data below shows the mile runtime for runners on a certain primary school track team as a function of height. And I do look at the data. Height of runners goes from 100 to 180 upward, and mile runtime in seconds should go downward if my intuition serves me. Taller runners tend to be faster, and it does, though it doesn't have to. Write a linear regression equation for this set of data, rounding values to the nearest thousandth. We do the same thing, so definitely pause the video. This problem is identical to the previous problem in structure. Do this on your own and check that you get the same thing we do. So I'm going to go to stat, calc, and I'm sorry, stat, edit, and I'm going to edit list 1 and list 2. So I got 100, 110, 120, 130, 140, 150, 160, 170, and 180 is the 9th data point. Okay, that's good. And then I go to L2 and I type in the numbers that they're given to me. Yes, they do have to be in this order. 711, 680, and they have to be as exact as they're given to me. 660, 577. Notice that when I type right away, it immediately deletes the rest of the content from the cell. 499, 416, 401, 401, 378, and 360. Okay, so we plug those in. We go to stat again to calculate the equation. Stat calc linreg ax plus b is number 4. Y L1 L2 frequency list none. Store EduQ. I'm going to store it as Y2. Just because that's the only reason I'm storing it, and also so that you know how to store it if you need it. There we go. So that's it. Ax plus b, where a is negative 4.98166 repeating. So y is equal to negative 4.98, then 1 we're followed by a 6. We round up to 2. X, because we're rounding to the nearest thousandth. If you don't round to the correct decimal place, you lose a point. If you don't round at all, you lose a point. If you don't round correctly, you lose a point. So you want to be careful with this. Plus 1217.65. The next number is a 5, and then followed by a 5. A 5 and above, we round up, so 6. This is 2 points right there. Good. And now use the equation to predict the mile runtime for a team member who is 167 centimeters tall. This is an X value. The mile runtime, according to this chart, is a Y value. And we have to round to the nearest tenth of a second. And we do have to round to what they said. So 167 is here. So the mile runtime we should expect to be close to here. The issue with a model, a linear model, or any model that you choose, is that the model does not have to fit the data perfectly, because the data, in fact, is usually haphazard, and it's only approximated by a model. So the data doesn't have to be exactly right in the middle if this happens to be close to the middle. This is close to 170, not closer to 170 and 160, but it doesn't mean that the answer is going to be closer to 378 than to 401, because the model, it's a model. Once again, it doesn't have to match the data perfectly. So y is equal to negative 4.982 times x is 167 plus 1217.656. What this conversation does, though, is it helps you to evaluate whether the answer is correct. So in other words, this conversation is a check. So let's see, negative 4.982 times 167 plus 1217.656. Okay, and then we get 385.662, which is in between 401 and 378. So that's a pretty solid check. We know that this is the right answer. So y equals 385 point, and then we round to the nearest tenth of a second. So 6 followed by a 6. That second 6 tells us to round up to 7. And do not put units. Okay, so that is our answer. That's what they're looking for. That's 4 points. We rounded to the nearest tenth. We didn't put units so that we don't accidentally get the question wrong for no reason. We answered the question as they wanted it. We used the equation that we got from rounding the coefficients to the nearest thousandth, as opposed to using the equation that we stored over here, which has a ton of extra digits. Okay, so if you see up here, a ton of extra digits. We used the one where we rounded. So we used all the information that they wanted us to use. So that's it. Hopefully you got it. Listen, keep working at it. I believe in you. All it takes is a little extra work. So hit that like button, subscribe, let your friends know that we're here. And thanks for watching. Stay tuned for the next video starting right now.